So welcome to this video. This is lesson G, null pointer exceptions, and how we use short circuiting to prevent a null pointer exception. I found some really funny comics about this. You can read them if you want. So here's our first do now. I'm going to pause this and write in the answers. You can pause the video too and write in your own answers and then check to see if you got it right. So 1, 2, 3, pause. So here are the answers. I hope you got them all right. Next slide. Here's another do now. So I'm going to pause and you can do a pause and we'll see if we all got it right. So 1, 2, 3, pause. Here are the answers. I just want to point out that there is no z in the string, so you get a -1. So when you're asking for the index of something and you can't find it, returns a -1. And char at 20 gives you an index out of bounds exception because there is no position 20 in this string. So the lesson for today is going to be talking about null strings. So first, let's just think about the word null. The word null is very similar to the words true and false in that true and false and null are considered reserved words, which are words that you're not allowed to use as names of variables or names of classes or names of methods. They have special meaning. They also make up part of the whole mess of keywords that are also considered off limits, like the word if and else and for, and the word public, static, void, all of those special words that really have special meanings. So null really means nothing. It means that there is no reference or no address, or the object literally doesn't exist in memory. So let's go to the next slide. So if you have a null string, let's look over here. So if I make a variable called word2 and I store the word null in it, I literally can say, let's have a string variable called word. Oh, actually, I'm sorry, I didn't notice it's up here. So string variable word2 is equal to null. Null means that we just don't have an address for this object yet. So the word2 variable is referring to no object, and no object has been created. Over on the left here, string word1 equals empty string. An actual object has been made. See my little cloud? And it actually has a string in it, but the string has nothing in it. We have an address for the object, so the address is what's stored in this word1 variable. The word1 variable is known as a reference variable because it stores a reference to an object. So word1 references an empty string. Word1 actually has an object that's been created. Now up here, look at this. You might be asking yourself, why would you not initialize a string? Or meaning, why would you not create a string object? Why would you just create a variable and then not have it pointing to an object? There are reasons, and it happens, absolutely happens in Java. It typically happens when you have a method that's returning a value that returns to another method that then returns another value to another method, and things get returned along the way, and eventually somehow the mistake is made and nothing is put into the string variable. So we'll learn more about this in the next unit. So this is an example of a line of code that will generate something called the null pointer exception. So in the line 5 right here, string s equals null, meaning I haven't created the object yet. I've created a variable, I have this variable s, but I just don't have an object yet. So if I say hey, I want s.length, because there's no object, s is a null variable and you're going to get a null pointer exception because there literally is no object to even find the length of. So s.length is going to give you an error. So over here I wrote, there's no object. How can you find the length of an object that doesn't even exist? And then the reference variable exists, but it does not have an address. Here is an example of how we can prevent a null pointer exception. And the way we prevent it is we have an if statement right at the beginning of a method. So notice how this method accepts in a string. We want to make sure that the string that we're accepting in actually exists. So we have this little if statement saying that if the a variable is null, meaning there's no address in it, or a.length is 0, we're going to give a warning. Otherwise, we can go ahead and do something with that a variable or the a object because we know the a objects exists. So I'm running the method twice here. So the first time I'm running it with a null string. So I have s. You know what? I'm going to erase. Here, let me erase. I'm going to erase all this stuff that I've drawn. And I'm actually going to make some object clouds here. So in this first thing, I make a s variable, but stored in the s variable, I should make this little box bigger so I can actually write the word null. I'm going to write the word null because this is really not pointing to anything. Then I'm calling safe method with the s. So what really happens is the contents of the s variable come down here to the method, and I make an a variable that has the same contents of the s variable. So the a variable gets a copy of this null. And now I'm saying, well, if a is null or a length is 0, we've got a warning. If it did exist, we'd be okay. So now let's try this again with the next set of code. Let me erase. This eraser is really small. I tried to make it a big eraser, but just not quite working. Okay, so now let's try it with s equals word. So here I make an s object. It's got an address in it that points to an actual string called word. There we go. And then I say, call the safe method. So the safe method, I go down here and I make an a variable. And the a variable gets a copy of the address that's stored in s. So that means that the a variable is also pointing to this word object. So when I say if a equals null, well, that's false. Why can I not? Ooh, whoa, something really weird what happened. This is odd, okay. A equals null is false. A.length equals 0 is also false. So this whole entire if statement just does not happen. And instead, I actually know I'm safe to do something with the a variable. Right here, I just have a message that prints saying string is okay. But in reality, once you've tested to make sure that it's null, that it's, really a string, you can now do stuff with that. So a lot of times what you do, instead of test, what you really want to do is say, well, if word is not null and the length is greater than something, then you can do, you're safe to do something. Here we just happen to have two different. So if word is not null and the length is greater than 3, we know we have at least a 3-letter word. Otherwise, if word is not null and the length is less than 3, we can say, oh, word is too short. If it fails both of those two tests, then we know that the word is null. This is kind of like our warning. Oops, word is null. So here we've got an example where we're going to write a method that takes a string as a parameter and returns the first word. So to find a word, we are looking for a space. Notice how in this example right here, the entire thing is considered a word because there are no spaces. And here, because it's all spaces, there's literally no word, so we return an empty string. And here, we've got a lot of extra spaces in the front. I'm going to show you what to do with that lots of extra spaces. So here, let's just remember that if a string has no words at all, the method should return an empty string. So here, no words, we return an empty string. And we also don't want to forget about short-circuiting to test that the string, to make sure the string is not null. So ready to write this? Let's go. So we have public static string first word S. So the very first thing I'm going to do is I'm going to test to make sure that if S equals null. Now the word null is actually like a primitive. So we can actually just test to see if what's stored in the S variable is equal to this null value. We don't have to do S dot equals null, because des.equals is a method of the string class. And because we don't even have a string that exists yet, we can't even call that method on S. So we have to just say if S equals null. So if we're null, or S dot length equals 0, we are going to return an empty string. So now that we've tested that, we can go forward with the real code. I just want to show you that this first if statement is an example of short-circuiting. Because remember, with an or statement, if the first part is true, if we have this first part is true, it's not even going to go do the second part. And if it's null, you really don't want to go do the second part, because you would be trying to take the length of a string that doesn't exist. That's not a good thing to do. You would get a null pointer exception. So this is how we use short-circuiting to prevent a null pointer exception, by first testing if it's null. And if that is true, it's not even going to look at the second part, and it's simply going to return an empty string. So let's write this. So we want to first find the index of the space. So I'm going to say int index equals S dot index of, capital O, index of a space. Now, it could be that we don't have a space in the string. So what we're going to do is we're going to say if index equals -1, meaning we don't have a space at all. Because remember, index of space will return a -1 if there's no space. Then we know the entire string is a word, and we just need to return S. Otherwise, we are going to take that index and we're going to return a substring, s.substring, from 0 to that index. Now, index is exclusive, which is good. So suppose our string is Amy space Smith, and we're trying to get that first word, which is Amy. So we're going to find the index of the space, which is at 0, 1, 2, 3. The substring is going to go from 0 to 3, which is exclusive, and that's all good. So this is the method that you want to write, called first word. It's using short-circuiting to prevent a null pointer exception, and we're also actually testing to see if the string is null. And that's it. So at the end here, as a summary, on the left here, the string exists, but it's an empty string. So that's kind of like a roll of paper towel that's just, or toilet paper that's empty. But over here, there isn't even a roll of toilet paper. So that's called a null string. It doesn't even exist. So I hope this helps you. If you have questions, let me know.